All right, so let's take a look at the problem set from the end of lesson 5. This is sort of an extension off a homework I gave you previously, in which you were supposed to have learned that the graph on an XY coordinate plane of a proportional relationship always produces a straight line, like the one we see here, and that straight line always contains the origin, or the point 0, 0, right here. And we've talked about this in class too. We've talked about why it has to be a straight line. Because if the line starts to become any more steep or move upwards at any point, that means whatever value or quantity is being measured on the y-axis is starting to increase at a disproportionately faster rate than whatever quantity is being measured on the x-axis. And if the line starts to move down in any way for any reason, well, that means that the quantity that's being measured on the x-axis is increasing at a disproportionately faster rate than the quantity on the y-axis. And then it has to contain this point 0, 0, or the origin, because when we talk about strict proportionality in the sense that this book wants us to understand it, we always take our x value and multiply it by some constant of proportionality to get our y value. And 0 times any number, no matter what our constant is, has to be 0. If your line touches the x-axis at any other point other than 0, 0, like say it touched here at 0, 200, well, you might still have a straight line, and then you would have what's known as a linear relationship, but those are like a greater subset of relationships. We want to talk about just the strictly proportional ones as defined in this book. All right, so hopefully you find this to be one of the easier homeworks I'll assign you all year. You look at number 1, you're just supposed to look at each one of these graphs and tell whether or not it's proportional just by looking at it. And A, yes, is proportional, and the other two aren't. And over here is where I think you should write some sort of explanation for your reasoning. And your reasoning should be something as simple as graph A contains the origin and it is a straight line, while the other two, well, this one's straight but it doesn't go through the origin, and this one is got a big crooked part in it, so that's why these two can't be. All right, number 2, go ahead and place these ratios in the table. So let's hear the ratio 2 to 22, 3 to 15, and 1 to 11. And then graph them really accurately on here. Let's see here, 2, 22, 3, 15. So let's see here. They didn't give us a 15 on the axis here, so we got to try to put our 3 right. 3, 15 right in the middle of 14 and 16. Notice I always say the comma between the x coordinate and the y coordinate when I say a coordinate pair out loud, because when I say 3, 15, that sounds much different than when I just say 315. You might think I was saying the number 315 without the comma. All right, and then 1, 11. Be really accurate on this, please. All right, and then we could try to connect these points, I suppose. I've got a ruler here, but I think it's pretty clear to see that those 3 points aren't going to make any sort of straight line. So that would be the explanation you want to use as to why this isn't going to form the graph of a proportional relationship, because the line is all crooked. You could also tell this isn't proportional by, looking at the values and maybe creating an extra part of the table here, calling it the y divided by x, right? And you could check these values and you would see it wasn't proportional that way. But I want you to focus more on the xy coordinate graph here. So the last part here is essentially identical to question 2. I have a feeling that you won't find it too challenging, so I'll let you do it without my help.